be doing this lab called Density Lab. Do you want to go grab it? It's right here in the coming up or to-do list, or you can go to the modules. And keep in mind that classes are recorded. If you need help with some of our class topics, I went in and fixed the links to the videos. So now they're easily accessible. You don't have to sign into iCloud. So if you need help with charting, we did that. One of the last things we did, organizing data with numbers, and there's a video on that. So I'm recording videos for those who are quarantining, those students who are still in a different country and waiting for their visas, and being able to travel over here. So this information is available for you too if you want to see something again. So go ahead and grab our file for the day, and it is called Density Lab. Always watch for extra information that I give you in the assignment. Don't just grab the file and then think that everything is in the file. When I have classes, I've got 5 classes, and so I've done this twice yesterday, and I might not emphasize something in class, and so I try to make it better so there's less questions up front. But if you have a question, let me know here in class or follow up with me by email. If you're not sure how to do something, then check in with me, maybe even run your lab by me before you turn it in. And I wanted to highlight a few things that came up, formatting your data, and this is one I just mentioned. And I'll point it out when we get inside the lab, but only create the bar chart for density. If you try to do it for all the data in the data table, you might think the data table looks beautiful and that's what I expect, but no, it's got to pass the common sense filter in your head. Can you look at it and know what it's telling you? Is everything clear? Everything labeled? And so that's the goal, making it simple. Just keep that in mind. You're going to combine your data with the lab write-up. Here's the lab write-up in blue. So I want you to open that up. We'll go over it. That's the lab write-up. But you're going to do your data inside of the Numbers app, just like we've done a couple of days now. And when you have your data table and chart, export it as a PDF file and send it over to Notability. When you do that, it's going to say, do you want to create a new note or do you want to add it to an existing note? Add it to an existing note right here, Density Lab. Don't turn in 2 files, you're turning in 1 file. That's all combined. We went over the steps to the scientific method. Observation, question, hypothesis, procedure, run your test, gather your data, draw a conclusion. So when you send your data over to the lab write-up, it puts your data at the very last page. That's not where data goes in the experiment, is it? Almost. It's data and then conclusions, but now it's going to have your data after the conclusion. So you have to then move that page up 1 page so that it doesn't come after the conclusion. Make sure you know how to format the data table. Remember also that the unit of measure goes in the column heading and not in every individual cell. Every cell is a calculator. If you put in text like grams, it changes the number into text and now you can't do math with it. Don't pull out a calculator today to do your math. Use the power of every cell inside of the spreadsheet for that. So if you're still a little rusty on data tables and charts, don't have your lab partner do it for you. They can help you. But I'll come around, and if you need help with something, let me know, and we'll try to shore up your knowledge on how to make data tables and charts. This being the 3rd time we're doing it, this is a pretty simple data table. You should be able to make it within 5 to 10 minutes. You'll even get faster than that, and it will be something that you just do naturally then. So open up this data lab right there, and we're going to go over this together. we're going to calculate the density of both solids and liquids. And this is an interesting picture. It has water right here, but it's been dyed with red food coloring. And if we were to take a spoon and mix this up and stir it, after a while they would separate back out again. Each of these colored layers, honey, corn syrup, dish soap, and vegetable oil along with water, they have different densities. So the lighter ones go to the top and the heavier ones sink. That's what density is. Can you guys figure out which one is heavier? Right. This one is heavier and this one is lighter, but they're the same size. So that's what density is. Density is how much mass you have in a particular space. So that's why we have a scale. We're going to weigh this, and then we're going to calculate the volume. You might know some geometry. We could calculate this with a ruler, right? Anyone know how we would get the volume of this square? What measurements do we need? Correct. The length, the height, the length, and the depth. Length times width times height. So if we did it in centimeters, maybe 1 centimeter times 1 centimeter times 1 centimeter, that would be, the answer is still 1, but don't forget the unit. It's 1 centimeter cubed. That's the volume. So we're going to use the graduated cylinder. And we're not going to do this in the lab. At your table, you have small solids. It's a square, a rubber stopper, and like either a glass or a metal ball. So we could do math on this too, but we're going to do water displacement. We'll fill this up with some water, record what our starting is, drop this in, and the water level goes up, and then we subtract the original amount of water. So this is called displacement. We're going to find out how much water this guy has displaced, and the water level goes up. You could figure out your volume the same way. And sometimes people are really into fitness, and they want to know their body density. They want to know their fat percentage and their muscle percentage and everything. So they actually can dunk you into a tank. They figure out how much space and volume you take up, and then they weigh you and they know the density. So it's a pretty easy thing. I wanted to just go over it so you don't make it complicated. So there's just a couple of math things that you're going to do. So the objectives are pretty clear. You're going to learn how to be accurate. The scale is no problem. You're just going to read what the scale says. So there's no error there. But be really accurate reading this guy. You have to have your eye at the level of the water. You can't really see the volume from this distance at an angle. So get down with it. And maybe you even have to have a colored background, because it is water. It's pretty transparent. So sometimes it's hard to see. Maybe try a dark background, and I'll show you where the error can be in reading that in just a minute. You're going to make a data table and chart, and you're going to combine it using Notability. So those are the objectives. So there's the formula that I've been talking about. Density is mass divided by volume. And I like this. This is the first time I've seen this. How do I know that it's not volume divided by mass? They said if it's like this, the M looks like the top of a heart and the V is like the bottom of a heart if you were to draw it. So use the image of a heart to remember which item is in the numerator. I thought that was pretty interesting. And there's the water displacement. It's good for irregularly shaped objects. Like if I wanted to get the volume of this little styrofoam bus, I really can't do it with the rectangle method. So you're going to do water displacement. Fill up water, drop it in, it goes up, subtract the original water. Scientists often compare the densities of one thing to another. Does anyone have a saltwater aquarium at home? They're really pretty fun to have because you can have very colorful saltwater fish. But you have to be a little bit of a chemist to keep that running smooth, and the salt content has to be just like the ocean. It can't get too salty, and you can't have too little salt, and otherwise the fish are going to suffer. So you're kind of constantly checking the salt level. Water will evaporate and make the aquarium more salty, and you can test it with this little scope. You just put a drop of water on it, look through it, and it will tell you what the salt is compared to pure water. Pure water has a density of 1 gram for every 1 milliliter. So if I were looking at this, here is a density of 1.5 grams per milliliter. If you compare that or divide it by the density of water, now you have a comparison number. This is called specific gravity. So this paragraph up above said, scientists are often comparing the densities of something to water, or if it's a gas, they compare it to air. Is it going to float and go up higher into the atmosphere, or is it going to sink? Is it going to form a layer up in the sky? So that's called specific gravity. It's really comparing one density to another. So if the number is less than 1, it sinks in water. No, excuse me, it floats in water. If it's heavier than 1, like 1.5, it sinks. Here's the equipment that you're going to need. Someone said, what do we call these? One on the left. What's this one called? Say again?
The beaker.
Yep. And it has marks. Almost all beakers will be graduated. When it has milliliter measurements, that's a graduated beaker. This is a cylinder. It's got markings on it. It's a graduated cylinder. Even this pipette has 3 lines on it. Take a look at it. Each line is a milliliter, so that's a graduated pipette and an electronic scale. So our equipment's pretty easy, and you're going to get the density of water right from the faucet. You're the first class of the day, everything is dry, so that's good. But imagine if you walked in and this has a little bit of water in it already. You're not going to weigh it and expect it that it's empty of water, and if you just had a little water on the inside, you're going to pick up the weight of the water. But like I said, you guys don't have to worry about that. It is empty and dry. Just make sure, like, tip it over, and I'm pretty sure I emptied all the water, but make sure. So you just put it on the scale, and then you write down your result. Now, here's where I want you to be exact. Pour exactly 20 milliliters of water. And as I mentioned, you could make a mistake with reading this. Water has molecular forces, just like those hairs on the bottom of a gecko's feet. It has a lot of electrons on the oxygen side of water, H2O. So it sticks to itself, and it sticks to the sides of the wall of the graduated cylinder. See how it kind of bends? So are you going to read this in the middle or on the edge? You read it in the middle. You read it at its lowest point. Because this is like Spider-Man. It's starting to stick to the walls and it rises up. That's not its true measurement. This is called the meniscus. So you read this as 40, 41, 42, 43, not 43 and a half. Be accurate. Don't round it up in your mind. You have to go to the nearest 100. This guy is even more accurate than this one, because this one shows half of a milliliter, and then there's space between it. And if it does go between it, you would say that it's 17.55. So It's pretty clear. I even made a new copy of this, and it says record to the 100th. So if you are just doing 20, for example, you're going to do 20.00. You always record all of your volume to 2 decimal places. The scale goes to 1 decimal place. So back to the directions again. Once you have exactly 20 milliliters, and that's why you have a pipette, you also have a little beaker here. Why not fill this up with some water, and then with the pipette, you could then add a little bit to your graduated cylinder to get it just right. If you overshoot it, take some water out with your graduated cylinder. This is the only time where I want you to be really accurate and hit that right on the dot, 20.00. When you have 20.00 milliliters of water in there, put it on the scale and weigh it. Then subtract the original weight of the graduated cylinder, and now you have the weight of just the water, right? So you're calculating the density of pure water. And then the next part, there's a rubber stopper. It says half fill, and people are like, well, should I go like 12 and a half, 13? No, just eyeball it. Just pour it in. And if you have 20, that's okay. If you have 25, that's okay. And it doesn't matter if it's right on the dot. Then you're going to record how much you start with. Put that in there. It goes up. Record that. Subtract the original volume of the water you started with. And now you have the volume of your object. That's water displacement. Then you're going to do 2 solids. The square and the sphere, like I was just showing you. All right, now take a look at the data table. It says raw data. This is just a place for you to write down your results during class. You are going to do your final in the Numbers app, but you can jot things down here and be messy. So when you format this in Numbers, format it to 1 decimal place here, 2 decimal places there. It turns out that if I can only be precise to 1 decimal place, and I'm really accurate over here to 13 decimal places, if you do math with those 2 numbers, you can only record the least precise number, accuracy. So notice when you calculate density, you can only go 1 decimal place. That's grams divided by milliliters. That's this divided by that. I was more accurate there, less accurate here, so my answer has to be the least accurate measurement. So I tried to be real clear. 1 decimal place, 2 decimal places, make sure you format that. How do you format? If this was in Numbers, tap on the table, then this is column B, you'll tap on the letter B, it highlights the whole row. Then you hit the paintbrush format and format the number to 1 decimal place. Let me know if you need help with that. Over here, I said create a chart for the density column only. When you create a chart, you're going to just tap on this number, select down to here, and then hit create chart. You only select the data when you make a chart. Don't select the column headings. The wizard in the Numbers app will grab that for you, and it does most of the work automatically. When you're in the Numbers app, as I mentioned, you're going to export your Numbers data table and your chart over to Notability. Please don't forget to hit the selection button that says Fit to One Page. I noticed some of you, when you were doing the other exercise, you forgot to do that, so your chart got cut off. You only showed half of it, and then the rest was gone. And you thought that was okay? So make sure that it makes sense and that you can see that everything is there. And it does it automatically if you hit over in Numbers, Fit to One Page when you're exporting it. Here are your conclusion questions. Pretty easy. Answer these 5 questions. And that's it. So now, form your group. If you need help with a lab partner, I will help you, but don't be shy. Go to a table where there is 1 person or 3 people, and you can round out the groups. And you can choose what lab table you're going to go to. Yeah? Just go to a lab table. It's not your seat partner. You can go to any lab table.